This is the balanced reaction for combustion of some hydrocarbon like alkane, alkene. And suppose this reaction gives K unit of energy per mole. So if you are using 2 moles of this fellow, then the energy will be 2K unit, whatever unit, calorie or joules, whatever you are using. So while right now we are talking primarily about calculations involving various things involved in a chemical reaction, later on you will also see how energy fits in so easily into this discussion. In thermodynamics, you will see lots of these things coming. So there also stoichiometry will help. Now, problems based on hydrocarbon combustion. The question goes like this: the percentage by volume of C3H8 in a mixture of these three is 36.5%. Calculate the volume of carbon dioxide produced when 100 milliliters of this mixture is burnt in good supply of oxygen. Enough supply of oxygen. Now, when you burn this mixture in enough supply of oxygen, then hydrocarbon will burn exactly like this. This and this both are hydrocarbons. So just apply CXHY formula for both of them. Carbon monoxide is also going to react with oxygen, and that will form carbon dioxide. All three will react with oxygen. So for this XY, X plus Y by 4, X CO2 plus Y by 2 H2O. Under the condition of constant temperature and pressure, like imagine you are doing this experiment in your laboratory, school chemistry lab, and pressure is atmospheric pressure, temperature is whatever is the temperature on that day. So those things are not going to change. So in such situation, these are gases, by the way. Small alkanes are all gases. Petrol is liquid because it's not very small alkane, 7-8 carbons, so it's liquid, but small alkanes are gases. So gas, gas, gas. PV equal to nRT. Pressure and temperature constants, then volume is proportional to moles. Why is it important? It's very important. Because reactions work by particles. Particles means moles. So whatever law we apply, that 1:3 ratio we say, or 3:4 ratio we say, that language is talking about particles, or that language is talking about moles. And if you know that volume is proportional to moles, then you can talk that type of language for volume also. That's why it's so important. So 36.5% by volume. 1:3. We want to know volume of carbon dioxide formed. Fine. So 1:3 relationship for moles, but because volume is proportional to moles, it will be 1:3 relationship for volume also. So 36.5 100 ml is there. 100 ml, 36.5% is 36.5 ml. So 1 ml gives 3 ml. So 36.5 ml gives 3 into 36.5 ml carbon dioxide. For methane, X plus Y by 4. Anyway, we don't care about how much oxygen is required. Oxygen is in abundance. So why really care about how many moles are required in this problem? Sometimes we do have to care, by the way. Those problems will come. We are right now concerned with the carbon dioxide. X CO2. X is 1. So 1 CO2. Okay. Now how much is methane? We don't know. Let's say V1 ml is methane. So 1 ml, 1 mole gives 1 mole. So V ml will give V ml. So V1 ml will give V1 ml. Now carbon monoxide. Carbon monoxide will react with oxygen and will give carbon dioxide. And that's easy to balance. So 2, 2. Carbon monoxide, we don't know how much is there. Let's say V2 is there. So 1:1 relationship, 2:2 is 1:1. So 1:1 mole or 1 ml is to 1 ml or V2 ml is to V2 ml, V2 ml. So carbon dioxide in total will be 3 into 36.5 plus V1 plus V2. Now V1 and V2 are not known, but the good news is that you don't need to know V1 and V2 individually. You just need to know V1 plus V2. Can you tell me how much is V1 plus V2? C3H8 is 36.5. Total is 100. So how much is V1 plus V2?
So 100 minus 36.5 ml.
100 minus 36.5. That's it. So 3 times 36.5 plus 100 minus 36.5. Just calculate that and see if you are getting 173 ml. And any questions, if you have, then let me know.